So we talked up on the board about this square root of 25, right? We said, okay, well, what times itself is 25? It's 5. So the square root of 25 is 5. Right? Let's think about the cube root of 64. Okay, and this will be probably the last one we do without a calculator. What that means is we're multiplying something by itself 3 times to get 64. So since 4 cubed is 64, we say the cube root of 64 is 4. Right? Now we can use a calculator to do these roots. Okay, let me show you how to do that. So if you don't already have a calculator, go grab one. Or just look on someone that's sitting next to you and turn it on. That's a 3. Yeah, I was just basically copying the problem. Yeah. Now, I'm glad you asked that question though, because if there is not a number in that little check mark section, you assume it to be 2, right? So like if there's no number, you assume it to be a square root, as opposed to like a cube root or a fourth root or anything. Let's look at number 3. We've got the 5th root of 3,125. Now this is where it starts getting a little weird, right? Some number times itself 5 times. You might be able to make a good guess here just because that it ends in a 5, right? There's only so many numbers that when you multiply give you that. Yeah. It's 5, right? So, but I want to show you how to get it in the calculator so that way you don't have to spend time like trying to think through, especially, I mean, look at number 4. The 7th root of 279,936. Like, that's just ridiculous, right? So let me show you how to do that. You're going to hit the math button. It's the button that says math. And then you're going to pick the 5th option on here. Now, if you have one of the older calculators, it might be a different number on there, but if you're using the TI-84, should be the 5th option. So you can either type 5 or just scroll down to get to 5. Notice it has like an X and then the radical symbol, that root symbol. Looks like a check mark. Hit enter, and now it's sort of set up for you to just type in the values that you see on the paper, right? So if we want to find the 5th root of 3,125, you hit enter and you get 5. Let's do the next one. The 7th root. So math, go down to 5. We want to do the 7th root of 279,936. You get 6. So 6 to the 7th power is 279,936. So now that you know how to use a calculator, this should be pretty easy. If we want to find the indicated nth roots of A, okay, so this is just kind of a weird way of asking the same type of problem that we have in 1 through 4. You just have to write the expression that it's telling you. Okay, so it's saying the nth root of A. So in number 5, it's the 2nd root of 64. In other words, the square root of 64. Now, when that root is 2, like if it's square root, you don't actually write the 2 here. So I'm going to write this incorrectly first. You don't ever write that 2 there. If you do, I guess it's not the end of the world there, but you really should not. That is your just classic square root. That's the square root that you've dealt with all throughout. I don't know when you first learned that, but whenever that was. So what's the square root of 64? 8. Now, if you don't know that off the top of your head, that's fine. Just put it in the calculator. You can actually do a square root a little bit easier than that nth root. To get the square root in the calculator, you're going to type 2nd, and then type the squared button down here, right above the button that says log. And then you could just do a regular old square root. All right, so I want you to use your calculator to find the cube root of negative 27. Tell me what you get. Negative 3. Number 7, the fifth root of 243 is 3. Okay, I'm going to give you 2 minutes, and I want you to do 8 through 10. Okay, but don't start doing 11. I know you could probably do 11 through 13 in the calculator, but I want you to hold off on that. So I give you about like a minute or two to do 8 through 10, just to make sure that you're comfortable here. All right, what'd you get for number 8? 5, good. Number 9? Negative 6, good, good, good. Number 10? Oh, error. Okay, well, let's think about that. Why are we getting an error for number 10? Is the calculator just dumb?
Yes.
So yeah, if we've got 4, like some number times itself 4 times, and we want it to be negative 64, right? Well, before we sort of solidify what our answer is here, I want you to understand why the calculator is not really doing what we want it to do. Okay, but why? So let's back up and make sure we understand what the question is here, right? Which is there a number that when you multiply it 4 times you get negative 64? The calculator is saying no, but why? Is there a number that times itself 4 times gives you positive 64?
Yes.
What would that be? Oh, very good, Julia. Yeah, so when you multiply 2 negatives, you get a positive, right? So like, no matter what this number is, if you have an even exponent, the answer is always going to be positive. It doesn't matter if this is positive or negative. So you can't have a real number multiplied by itself an even number of times end up to be negative, right? Because even if x was negative, the negatives would cancel out for each pair. So in this case, we're going to say no real solution. No real solution. Now for 11 through 13, you're seeing these fractional exponents. Another way to state them is that they are rational exponents. So a rational number is just a number that can be written as a fraction. So quite often, instead of using the word fraction, we use the word rational number. So instead of a fractional exponent, we have a rational exponent. It basically means the same thing. So what I want to do for you is explain what it means to have a rational exponent, or in other words, a fractional exponent or a decimal exponent. So whenever you have a fractional exponent, what that means is that you actually have some kind of root going on there. Okay? So you may wonder, what does it really mean, I'll just write this over to the side, to have the square root of x? Right? Now, we've talked about like what that means, like in terms of, oh, it's just some number times itself, right? But this little check mark thing that we call a radical is really just a special notation for something else. And what that something else is x to the 1/2 power. That's really, like if I say what is 25 to the 1/2 power, all that means is the square root of 25. Those things are, they mean exactly the same thing. Okay? Which means, like, if I have the cube root of x, what does that really mean? X to the 1/3, right. If I have the 4th root of x, what does that mean? Yeah, x to the 1/4. So once you understand that these radicals or checkmark looking symbols, what they're really saying, then you can always just rewrite it like this. And so some of the questions I'm going to be asking you is to rewrite a rational power as a root and vice versa. Okay? There's one other little thing here, and you might notice that like all of these fractional exponents or rational exponents have a numerator that's 1. So what happens if that's not 1? If it's like 2 or 7, or, you know, like if this is x to the power of 7/2, something like that. If you have an exponent that's a fraction and the numerator is not 1, then you're actually going to raise that root, whatever it is, to that power. So let me show you what I mean by that. If you have like x to the 3/2 power, then that really just means the square root of x to the power of 3. Okay, if I have something like x to the 5/7 power, Jackson, you with me? All right. So if I have something to the 5/7 power, what that really means is the 7th root of x to the 5th power. So in general, we can say that x to the power of a over b is the bth root of x, sort of a weird word there, bth, to the a power. So this is like this is the property for today. Last time we did like 8,000 different properties. Today's just one. I want you to understand this relationship here. So as we go through these, we're going to be rewriting these to make it easier to type in the calculator, basically. Now, if you're just evaluating this, like you could just type it in the calculator, right? Like, do y'all know how to put exponents in the calculator?
Yes.
Yeah, so we can do that pretty quickly, right? What is 625 to the 1/4 power? 5, yeah. What's negative 216 to the 1/3 power? Are y'all noticing a little pattern here? Right? This and this is the same. The cube root of negative 216 is the same thing as negative 216 to the 1/3 power. So then, without using a calculator, if we know that the 4th root of negative 64 has no real solution, then what is negative 64 to the 1/4 power? No real solution. Exactly. All right, let's take a look at the back. All right. So these are going to be some of the questions I'm asking you, just asking you to kind of go back and forth between the rational exponents and the radical form. So when I say the rational exponents, I mean like just write whatever the base is to like some fractional exponent. And if I say write it in radical form, I mean like with the check mark, with the radical itself. Okay, so this is where we're going to practice kind of going back and forth between the different ways we write these. Maybe we'll have time at the end of the period. We can talk a little bit more about that. So 6 to the power of 3/2. Okay, so I'm not asking you, so the one thing I'm not asking you to do here is I'm not asking you to tell me what that equals. I figure you know how to put that in the calculator. That's not what I'm asking. I'm asking you to write this in radical form. So basically what I'm asking you to do is take something that's written like this, right, x to the a over b, and rewrite it as the bth root of x to the a power. Okay? That's all. So here, which root, like what's going to be the number that's on the inside here? Like what root am I actually taking here? So 6, like, but is it like the square root, like the third root, the fourth root, or what? So the square root, right? So the square root of 6 cubed. Now if you just like sort of like are going fast and you actually write the 2 there, that's not a big deal, that's fine. But typically you won't see a 2 there if it's a square root. Number 15. 12 to the power of 3/4. When you rewrite that, it'll be the fourth root of 12 cubed. Number 16. We've got the fifth root of -3 squared. All right. Any questions about any of those? So this next section, we're just going the other way. Okay, so I'm giving you the radical form of this rational exponent, or this rational power, and I want you to write it in exponent form. So go from this to this. So what's going to be the fraction on the exponent for number 17? Like it's going to be 5 to what power? 3/4. Yeah, 3/4. Number 18 would be -8 to what power? 2/3. Number 19 would be 15 to the power of 7/4. Good. Now what we're going to do is kind of bring back some of those old exponent properties and combine them with what we have here. Now this is where I would say, yeah, let's start to use a calculator, because we're going to have to like add and subtract fractions. Yeah, I don't want you to like get that wrong because your fraction skills are weak. So number 20, if I'm multiplying two things that have the same base, what do I do with the exponents? Looks like those rules are still, oh no, I erased them. You add them, right? Like, so what's -1/5 plus 3/5? 2/5, yeah. So 4 to the 2/5. That would be your answer there. If I were to go write that in radical form, this doesn't ask you to write it in radical form, but if I did, it would look like this. The fifth root of 4 squared. But this is fine. If you're just simplifying, if it doesn't say to write it in a certain way, you could write it in any way you want. All right, number 21, same kind of deal here. We're multiplying two powers with the same base, so we need to add the exponents. So 2/3 plus -1/6. Is that really 1/2?
Yeah, I know.
Well, look at that. So that's x to the 1/2 power. How would I write that in radical form? So it'd just be, it's just the square root of x, right? There's an assumed 2 here, and then to the first power doesn't really change anything, right? So it would be like if you wrote it like this, but that's just like sort of a more complicated way of just saying square root. Now, if I'm dividing two powers with the same base, what do I do with the exponents there? Subtract. So what's 2/5 minus 1/2? Negative 1/10. Okay, so a to the negative 1/10. Now, I'm not allowed to write this with negative exponents. So I need to rewrite it as 1 over a to the positive 1/10. Which would be like 1 over the 10th root of x, or of a. Oh, look, I wrote x again. Look at that. So the 10th root of a. All right, we've got a couple of word problems here, and typically these are going to be pretty easy. I think you just have to understand what it's asking. It says the area of a square patio is 121 square feet. What's the length of each side? Well, what's sort of the key thing that we got to know about a square? Yeah, the sides are the same, right? So what we have is s times s, or s squared is 121. So to find that side length, we just take the square root of both sides. So what is the square root of 121? 11. Yeah. Or 11 feet. Number 24 says you have a brand new Rubik's Cube for Christmas. That's what I was asking for Christmas. Okay, so you got a Rubik's Cube. The box says it has a volume of 42.875 cubic inches. What is the length of each side? So how do we find volume of a cube? This cube, right? How do we find the volume of a cube? Yeah, just multiply the three dimensions together, right? And in a cube, all the sides are the same. So the side times side times side. In other words, the side cubed is 42.875. So how do you think we're going to find the actual side here? What would be the opposite of cubing a number? Well, how did we solve the last one? How did we sort of get rid of this squared? So the opposite of squaring something is taking the square root of it, right? So the opposite of cubing something is taking the we need to take the cube root of 42.875. And it's probably going to be a decimal. Oh, is it not a decimal? Oh, it's just a terminating decimal. That's great. Well, so what is it? 3.5. So 3.5 inches.